Imagine closing a wooden door. The sound feels ordinary. The movement lasts barely a second. But what if I told you that this simple object may have started life as a tree growing for more than 50 years in a distant forest? Most people never think about this. Yet behind every wooden door lies a remarkable journey involving forests, sawmills, drying chambers, precision machinery, and engineering that transforms living wood into a product designed to last decades. Think about this. Every year, manufacturers produce hundreds of millions of wooden doors worldwide. Some protect homes from storms. Others resist fire for hours. The most advanced models combine natural wood with engineered cores, precision hardware, and manufacturing tolerances measured in fractions of a millimeter. And this is where it gets truly extraordinary. Right now, somewhere in the world, massive saw blades are cutting through logs thicker than a person is tall. Kiln operators monitor temperatures around the clock. CNC machines carve intricate designs with incredible precision. Every stage matters because one hidden defect inside the wood can eventually twist, crack, or weaken the finished door. Today, we're following the complete journey of a wooden door. From sustainable forests and harvested timber to drying, machining, assembly, finishing, and quality testing. You'll see how nature and technology work together to create something you use every single day. But before a door can protect your home, it must first begin its journey deep inside a forest. Most wooden doors begin with species such as pine, oak, maple, birch, mahogany, or engineered wood products. Large forestry operations in Canada, the United States, Sweden, Finland, Germany, Brazil, and parts of Southeast Asia supply timber to manufacturers around the world. Different woods offer different strengths, appearances, and costs. Choosing the right material can determine the door's entire performance. The process starts with harvesting. Modern forestry equipment can cut, trim, and process trees in minutes. Giant harvesters grip the trunk, remove branches, and cut logs to precise lengths using computer-controlled systems. What once required teams of workers with hand tools now happens with astonishing speed and accuracy. But here's what nobody tells you. Freshly cut wood contains a surprising amount of water. Depending on the species, moisture content can exceed 50% of the wood's weight. If manufacturers skip proper drying, the final door may warp, swell, crack, or fail. That's why moisture control becomes one of the most important stages in the entire industry. After harvesting, trucks transport the timber to sawmills that may process thousands of cubic meters of wood each day. Massive circular saws and band saws transform logs into boards, beams, veneers, and engineered components. The smell of fresh cut wood fills the air while mountains of sawdust collect beneath the machinery. Many modern doors use engineered materials such as MDF, particleboard, laminated veneer lumber, and plywood. Manufacturers create these products by combining wood fibers or veneers with specialized adhesives under controlled pressure. The result offers excellent stability, consistent quality, and efficient use of forest resources. Sustainability has become a major priority throughout the supply chain. Certified forestry programs help ensure responsible harvesting and replanting. Many manufacturers recycle wood waste into fuel, particleboard, or biomass energy. What happens next surprised even experienced engineers when modern factories dramatically reduced waste while increasing production. Before production begins, workers sort every board according to moisture content, grain pattern, density, and structural quality. Advanced scanners identify knots, cracks, and defects long before assembly starts. Only then does the wood move toward the most important transformation of all. Because raw timber still isn't ready to become a door. Now the real manufacturing begins. Fresh lumber, engineered panels, adhesives, and hardware are about to enter a production system where heat, pressure, precision cutting, and automation transform natural wood into one of the most familiar products on Earth. And the first step determines whether the door survives for decades or fails within years. The first stop inside the factory isn't cutting or assembly. It's drying. Even carefully selected lumber still contains moisture that can threaten the finished product. Workers load massive stacks of wood into kiln chambers where temperatures typically range between 60 degrees Celsius and 90 degrees Celsius, or 140 degrees Fahrenheit to 194 degrees Fahrenheit. Over several days, powerful airflow systems remove excess moisture until the wood reaches a stable level of roughly 6 to 12%. When the kiln doors open, the transformation is remarkable. The wood feels lighter, more stable, and ready for precision manufacturing. Think about this. Removing moisture too quickly can crack the boards, while drying too slowly wastes time and energy. What happens next surprised even experienced engineers when automated moisture sensors began monitoring every stage in real time. Next, high-speed planers and molding machines shape the lumber into precise dimensions. Rotating cutter heads spin between 4,000 and 8,000 revolutions per minute, shaving away tiny layers of material with incredible accuracy. The factory fills with the scent of freshly cut wood as long ribbons of shavings flow into collection systems. Every board now begins to look like part of a finished product. For solid wood doors, manufacturers join carefully selected components together to create strong frames. Hydraulic presses apply pressures that can exceed 100 psi while industrial adhesives bond the wood. Modern adhesives create connections so strong that the surrounding wood often fails before the bond itself. Most people never think about this, but the invisible glue lines play a crucial role in every door. Many interior doors follow a different path. Manufacturers create lightweight cores using honeycomb structures, engineered wood, or particle board. Outer skins made from wood veneer or molded panels attached to these cores under heat and pressure. The result feels solid while using significantly less raw material. And this is where it gets truly extraordinary. Giant hot presses squeeze the assembled components together under temperatures between 120 degrees Celsius and 180 degrees Celsius, or 248 degrees Fahrenheit to 356 degrees Fahrenheit. Depending on the design, pressing cycles may last from a few minutes to more than half an hour. During this stage, heat activates adhesive systems and locks the structure into its final shape. After pressing, CNC machining centers take control. Computer-guided cutting tools carve hinge pockets, lock openings, decorative grooves, and custom designs with millimeter precision. Spindles rotate at speeds exceeding 18,000 revolutions per minute, while software follows digital blueprints. What once required hours of manual labor now happens in minutes. The freshly machined door then moves through sanding systems. Multiple sanding heads smooth every surface and edge. Fine wood dust fills extraction ducts as abrasives remove tiny imperfections. By the end of this stage, the surface feels perfectly smooth beneath your fingertips. Next comes finishing. Depending on the product, robotic spray systems apply stains, primers, sealers, or paint. Some luxury doors receive multiple coating layers, with drying cycles between each application. Under bright factory lights, the wood grain suddenly comes alive with rich color and depth. Workers then install hinges, lock preparations, decorative inserts, glass panels, or specialty hardware. Every component must align perfectly. A tiny error can affect how smoothly the door opens and closes. Think about this. A product you use in seconds every day may require hours of manufacturing and inspection. Finally, the completed door rolls toward inspection. It looks finished. It feels finished. But hidden defects, dimensional errors, and performance problems can still remain. That's why the next stage combines sensors, automation, and human expertise to examine every detail before a single door leaves the factory. The quality control process begins long before a door reaches the shipping area. As each unit enters the inspection line, high-intensity LED systems illuminate every surface from multiple angles. Cameras capture detailed images of the grain, finish, edges, and hardware locations. What looks flawless to the human eye can still contain defects measured in fractions of a millimeter. Modern factories increasingly depend on artificial intelligence to analyze these images in real time. AI vision systems compare every door against digital quality standards and instantly flag scratches, finish imperfections, dents, discoloration, and machining errors. Thousands of measurements happen in seconds. Most people never think about this, but some doors undergo more inspections than many automobiles. Laser measurement systems then verify critical dimensions. Door height, width, thickness, hinge locations, lock preparations, and frame alignment must stay within strict tolerances. Premium manufacturers often target dimensional accuracy within plus or minus 0.5 millimeters. Imagine maintaining that precision across thousands of units every day. But here's what nobody tells you. Wood remains a living material even after manufacturing. It expands and contracts with changes in temperature and humidity. That's why factories use moisture sensors to verify that every door maintains the correct moisture content before packaging. A small moisture imbalance today could become a major warranty claim years later. Some facilities also perform structural tests on sample doors from each production batch. Hydraulic systems repeatedly open and close doors thousands of times to simulate years of daily use. Others test impact resistance, screw holding strength, and frame durability. What happens next surprised even experienced engineers when certain designs survived hundreds of thousands of operating cycles. Fire-rated doors face even tougher challenges. Specialized laboratories expose test units to extreme temperatures that can exceed 900 degrees Celsius, or 1,652 degrees Fahrenheit. Engineers monitor heat transfer, structural stability, and smoke resistance throughout the test. These evaluations help determine whether a door can protect lives during an emergency. And this is where human skill still beats machines. Experienced inspectors often spot subtle grain mismatches, color variations, and finish issues that automated systems may classify as acceptable. Years of craftsmanship train the eye to recognize quality beyond numerical measurements. Technology provides data, but people still make many of the final decisions. Many leading manufacturers follow international standards such as ANSI, AWI, FSC certification programs, and fire safety requirements depending on the market. These certifications help ensure consistency, sustainability, and long-term performance. A door that fails certification may never reach customers regardless of how attractive it looks. Once approved, robotic handling systems move the doors toward packaging. Vacuum lifting equipment carefully transports finished products without damaging the surface. Sensors monitor position and movement continuously. Watching these systems feels like watching an industrial ballet performed with perfect timing. Workers wrap each door in protective materials before placing it inside reinforced packaging designed to survive trucks, warehouses, forklifts, and long-distance transportation. By this point, the product has passed through forests, sawmills, kilns, CNC machines, finishing lines, and rigorous testing systems. Yet the story is far bigger than a single factory. Because wooden doors represent a global industry worth billions of dollars, employing millions of people and connecting forests, manufacturers, designers, architects, and homeowners around the world. The scale is enormous. And some of the numbers behind it sound almost impossible.